All right, now, I have my textbook right here, and I'm going to talk about section 15.2. Okay, we have an aqueous solution. An aqueous solution, aqueous, I don't spell, wait, I know how to spell. Aqueous. An aqueous solution means you have a solute, a salt, or sugar or something, and you have water as the solvent, a water solution. Now, there are many, many different types of solutions. You can have air is a solution. It's a gas-gas solution. You can have water and alcohol as a solution. You can have water and any kind of liquid, two different liquids, as long as they dissolve in one another, that's a solution, a liquid-liquid solution. You can have gas-gas solution where you have air, you have nitrogen and oxygen. You can have different types of solutions. You can have a solid solution. For instance, brass. Look up the word brass. That's a solid solution. Look up the word bronze. Look up the word alloy. Alloy. That's a solid solution. So you can have different types of solutions. The solutions that we're going to really kind of key in on in chapters 15 and 16 are aqueous solutions. They're water solutions. So if I have a solute, say salt, in water, that's the solvent. That's an aqueous solution. Okay? Now, for instance, let's say I have HCl. That's a gas. Okay? You're going to have a gas. It doesn't have to be a solid. So HCl, hydrogen chloride, is a gas, and I'm going to dissolve that in water. And that's going to be HCl aqueous, AQ for aqueous. That's a water solution of hydrogen chloride in water. We think of that as an acid. Acid rain. One of the major gases in acid rain is another gas. Sulfur dioxide is the solute, and the solvent is water. And that is sulfurous acid. That's sulfurous acid. That's hydrochloric acid. You can get this. That's sulfuric acid, and that is usually a solution of sulfur trioxide and water. So, water solutions. You can have a gas, or you could have a solid. Okay, for instance, I could have sugar, glucose, in water. That's a solution. Easy? Yes? This is a non-electrolyte solution. Does not conduct electricity. Doesn't do it. Water is polar. It's a polar substance. But pure H2O does not conduct electricity. Doesn't do it. I'll tell you what does conduct electricity. If I take sodium chloride, solid, as the solute, and I put it in water as the solvent, and make a solution of nitrogen chloride. You ever hear of the word saline solution? If you go to the hospital and you need to be hydrated, they'll put a intravenous needle in you, and they'll hang a clear looking solution, and that's a solution of sodium chloride and water. Okay, saline solution. You can have a solution, a water solution, where you have ethyl alcohol. Okay, ethyl alcohol and water. Okay, ethyl alcohol and water. Okay, that's a solution. Okay, you can have methyl alcohol and water. You may at home use isopropyl alcohol. So this is isopropyl alcohol. That's actually an old common name. Propyl from propane, or 3 carbons, propane, and the iso means it's on the central carbon, isopropyl alcohol. And you can see the red oxygen and the OH is on the central carbon. Ethanol is next, very soluble in water, very soluble, and it's used quite extensively in the science laboratory, and that's the structural formula of ethanol, or ethyl alcohol. Next is methyl alcohol, from methane, methyl alcohol, and that particular alcohol is less soluble in water. So you have isopropyl alcohol, ethyl alcohol, and then finally you have methyl alcohol, all soluble in water to varying degrees. You can have butyl alcohol, isopropyl alcohol, ethyl alcohol in water. These are solutions, okay? So you have a solute and you have a solvent. This is usually salts. If it's a solid, it could be a gas or it could be a liquid. Okay? And then this is always water. Correct? That is an aqueous solution. Now, you have, if I take, that's methane. Methane is an organic substance. Does not dissolve in water. But if I take an organic liquid, such as octane, which is and I put, each of these is hooked to a hydrogen, you get C8H18. That's octane. It's a liquid, it's gasoline. It's a major component in gasoline. That will dissolve in gasoline. Okay? But this is not aqueous. It's not an aqueous solution. Remember, like dissolves like. Okay? So you can have methane dissolved in octane. It's a solution, but it is not a aqueous solution. You have soap. You have an oil end, and you have a charged end. This will dissolve the oil, yes? This will dissolve in water, and that's how you clean your hands. You use soap. So that's a soap molecule, okay? And it looks like this. It literally looks like gasoline. okay? And this is C, H, 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 and there's H's coming off of here. These are all carbons, carbon, 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 right? And so these are all bonds. So you have two hydrogens. So it actually looks like this. Okay, this is CH3, 3 hydrogens. Hydrogen, that's CH2, that's hydrogen. So here's a carbon, these are carbons. Okay? So you're writing it without writing in the hydrogens. Do you get it? So one end is CH3, okay? And the other end is C double bond O, charge. Okay? This is called a carboxyl group. We're not going to worry about that right now, but that's where the charge comes from. That attaches to water. Okay? And then this attaches to the water. This attaches to the oil. You can wash your hair if it's greasy, and that's how you clean your hair, or clean your hands of oil. You get oil on your hands from cooking, you use soap, that's going to dissolve in the oil, that's going to dissolve in the water literally pulls the oil off your hands. That's how it works. Okay? Why do we care about soap? Because soap is a surfactant. Remember surfactant? Surfactant can break down hydrogen bonding. If I have pure water, look back on section 1. Pure water, you have this hydrogen bonding. It literally forms this complex net, right? Complex net. And all the water molecules are held tightly together from these physical bonds called hydrogen bonds. The water gets in the way, so you don't have surface tension. And water will boil at a different temperature because you don't have the water, when it boils, it can go into the vapor state more readily. Clear? Okay. So, that's yeah, I'll let that go. I'll edit that out. Okay. And so that's solvents and solutes. Okay? Solutes and solutes. And then you have the solution process or solvation, but we'll do that in a minute.